Hey guys, this will act as a review for you for your studies of enzymes and how they work, which is the end of this unit. I'm going to launch this movie here, and we are going to watch it without the narration, and I'm just going to talk through it, and then we'll listen to it with narration. So here we have an end diagram of the reaction we're going to talk about. Talk about a larger substance here, okay, which could be a dipeptide or a disaccharide being split into a monosaccharide and a monosaccharide, or one amino acid and one amino acid. There's that larger substance. You see the colors will change to show that it's actually a combination of two smaller substances that can split apart. But that happens too slowly, so we need to use an enzyme. Here's an enzyme, and if you notice, I just paused the movie, there's this very custom shape, a very unique kind of a shape here. That's just to show that enzymes are they're very fickle. They will only react with certain substrates. So there are certain enzymes in a body that are pretty much only looking for certain substances, substrates, sugars, proteins, fats to work with, essentially. So there's your enzyme. The active site is where the quote-unquote activity will happen. And you'll notice the substrate shape will fit directly into that spot. And along that active site is where the enzyme acts on the substrate. And in this case, the enzyme is going to split the larger substrate apart into two new pieces. When they combine, it's called the enzyme substrate complex. It's a combination of the two. And the cool thing about enzymes is they kind of stay in the system and keep acting. They keep acting and keep acting. The products can go off, do things, the cell can use them for energy or whatever it is, or process them in whatever way it wants to, but the enzyme can keep accepting more of these substrates and act on them. You can see this animation repeats it a couple times. So like I said, we're going to now put the sound on, and we are going to watch that again. This time with sound.
Here's an example of a chemical reaction. One large compound is broken into two smaller compounds. This reaction takes place much too slowly to be useful in a cell. In order to speed up chemical reactions, cells make special proteins called enzymes. An enzymatic reaction begins when a specific compound binds to an area on the enzyme called the active site. The compound that binds is called the enzyme's substrate. Notice the shape of the substrate and the active site. They fit each other like a lock and key. In general, each enzyme's active site can fit only one kind of substrate, and so can speed up only one kind of reaction. When a substrate binds to the active site, an enzyme-substrate complex is formed. A slight change in the shape of the substrate weakens a chemical bond. This weak bond is easily broken, splitting the substrate into two pieces. The pieces, now referred to as products, detach from the enzyme. In enzymatic reactions, only the substrate is changed. The enzyme itself is unaffected by the reaction. After the products leave the active site, the enzyme is free to speed up another reaction.
So let's just not forget that the enzymes can actually act in the other way, which is to actually split, to actually combine together two smaller items together. And I'm just seeing if I could get that that image in our PowerPoint. So right here, you see a substrate going into an active site, and again a larger one being split apart. So this top reaction is what you just saw an animation on. So you have a substrate hitting the active site of the enzyme acting upon it, called the enzyme substrate complex along the top here, and then it splits apart. Notice the bottom example, letter B down here, two substrates come in, and then they actually bond together and actually form a larger product. So keep that in mind. A large substrate can be split into smaller products, or two smaller substrates can be combined into a larger product. I hope this has been helpful for you, and that's your coverage of enzymes.